In the first lesson of this training system, the trainee learns the basic components and operation of the thread roller. The trainee also learns the location and purpose of the machine controls, the procedure to start and stop the machine during normal operation, how to jog the machine, and all operator lubrication tasks. In the following segment from Lesson 1, the trainee is being shown the components and operation of both types of blank feed devices.
The purpose of the vanes is to load the blanks onto the feed rails. When the rotor vane feed is turned on, the hopper begins to rotate. This rotation causes the vanes to pick up blanks from the bottom of the hopper. As the vanes approach the top of the hopper, the blanks fall from the vanes onto the feed rail wings. The purpose of the feed rail wings is to guide the blanks into the feed rails. As the blanks move down the feed rails, they must pass under this clearing wheel. The purpose of the clearing wheel is to remove all incorrectly positioned blanks from the feed rails. The blanks which are kicked out of the feed rails fall back into the hopper. Here you can see the clearing wheel behind this cover on the outside of the rotor vane feed. The rotor vane feed is sometimes replaced by a vibrating bowl feed. This type of blank feed system consists of a vibrating metal bowl. The vibration causes the blanks to move around this bowl track. An air stream removes any incorrectly positioned blanks. The blanks then move into the feed rail.
Lesson 2 of this training system teaches the trainee how to inspect and measure both blanks and threaded parts. The terminology for blank features and thread features is also learned. Close-up views are used in the videotape to show examples of blank and thread defects, which the trainee must learn to identify. In Lesson 3, the trainee learns to begin a setup by removing and installing the thread roll dies. Selection and installation of the correct die packing is also shown. In the following segment from the Lesson 3 videotape, the trainee is being shown how and when to make and install a stationary die bridge.
These are die end angles. These angled surfaces are found on the ends of dies. Stationary die end angles are needed because the transfer space is angled slightly in relation to the die pockets. The purpose of end angles is to provide the correct surface angle for the blanks at the end of transfer. Two end angles are needed on duplex face dies since the dies must be turned around to use the second die face. The gap formed by the second end angle and the die relief on the second die face interfere with the movement of the blanks during transfer. This problem is prevented by making and installing a stationary die bridge. A bridge allows smooth blank movement during transfer. A stationary die bridge should be installed after the heights of the dies are correct. To make and install a bridge, cut a piece of 10,000 shim stock or spring steel. Then, make a slight bend along one corner of the bridge. Lock the transfer assembly. Then loosen the stationary die clamp lock nut. Install the bridge under the stationary die clamp. Install the bridge with the bent portion pointed down. Position the bridge so that it forms a straight line between the feed plate and the outer die end angle. Tighten the stationary die.
Lesson 3A shows the trainees how to measure, mark, and grind die relief. This lesson is optional for those companies where the dies are relieved in the tool room. Lesson 4 covers the setup of the blank feed system. Procedures for setup of both the rotor vane feed and vibratory bowl feed are shown, as well as adjustments to the feed rails and air lines. In the following segment from Lesson 4, the trainee is learning to perform final adjustments to achieve proper blank feeding.
Stream of air is blown out of one air line into the other air line. This air stream passes between the feed rails and the feed rail cover. When the feed rails become full up to the feed control air lines, the blank heads interrupt the stream of air. The vibrating bowl is turned off. When the row of blanks falls below the feed control air lines, the air stream resumes and the vibrating bowl is turned back on. To adjust the feed control air lines, be sure that there are blanks in the feed bowl. Then turn on the machine. Now adjust the feed control air line so that the airstream goes from one air line into the other. The vibrating bowl will begin to vibrate. Blanks will start moving into the feed rails. When the feed rails become full up to the feed control air lines, the vibrating bowl must stop vibrating. If it does not, you will have to readjust the feed control air lines. If the machine is not ready to start production, turn it off. Some machines have an additional blank loading bin installed. The purpose of the blank loading bin is to supply blanks to the vibrating bowl feed. This control arm rides on top of the blanks in the feed bowl. When the level of blanks becomes low, the control arm activates a switch which turns on this vibrator unit. The vibration causes blanks to fall into the feed bowl. When the level of blanks in the feed bowl rises, the control arm is raised and the vibrator is turned off. Many companies install.
Lesson 5 teaches the trainee how to set up and adjust the starter finger and the transfer assembly. The trainee will learn to select the proper fingers for a setup and to grind the required contours and clearances. Also, the procedures to remove, install, and adjust these components are covered. Adjustment of the installed thread roll dies is shown in Lesson 6. The trainees learn to adjust die squeeze to produce accurate sized threads. The trainees also learn to adjust the die height and to adjust the die match to properly form the threads. In addition, adjustments for specific types of dies, such as fluting, gimlet point, and knurling dies, are demonstrated. In Lesson 7, numerous troubleshooting skills are learned. The trainees learn to identify many problem indicators on the dies and on the threaded parts, and learn the probable cause and the appropriate corrective action for each problem. In the following segment from Lesson 7, the trainees are being shown how to shim the dies to roll full threads on tapered blanks.
Because of die wear in the cold header, some blanks are made with bodies which are tapered, yet still in tolerance. These blanks can be rolled with full threads. This is done by shimming the dies to produce a matching taper on the threads. Make an initial taper adjustment by using shims which are 3/1000 thick for double-aught and aught machines. On 10 and 20 machines, use 5,000 shims. Select narrow shims which are almost as long as the moving die. Jog to the end of the forward stroke, loosen the moving die clamps, and remove the die. If the tapered blank is larger at the top of the body, just below the head or shoulder, you must shim out the bottom of the die. Place a small amount of oil on the ends of the shims. This will help hold them in place in the die pocket. Install one shim against the back of the die pocket. Place the other shim at the front of the die pocket. Be sure that the shim does not extend past the edge of the die pocket. Then, carefully replace the moving die. Do not move the taper adjustment shims as you replace the die. If the tapered blank is wide at the bottom of the body, you must shim out the top of the die. Install one shim at the bottom of the back of the die pocket. Carefully replace the moving die.